Okay. So this question, December 18. Are you able to get the value given? Anybody? Have you tried this tutorial?
Yes, that's it.
Okay, Nidia. So are you able to get the value I wrote there?
Yeah. Yes.
All right.
It's the same with the one you write on the screen.
Okay, very good, Nidia. The rest? How about the rest? If I can share the I have a discussion on this question with previous group. So I asked the student to share the answer in the WhatsApp group. So Nidia, can you share your solution there? Can you?
Yes.
All right.
Yes, but not right now. I need to make it more neater.
Okay.
To make it
All right. Wait. I'll share the one the student gave to me previously in the other group. Can I copy this image? So that we can discuss. Where is the image? Okay, I have to copy that. Wait, because I have the answer scheme and also the solution in hard copy solution. So not sure whether this is a clear picture or not. Yes. This is for question, I don't know. Okay, maybe you can, or I share this solution. I share this this example with your, or anybody, because this is from other group actually. Okay, so anybody of you other than Nidia who, although you cannot get this the value shown here, but just give your solution in the WhatsApp group. Anybody willing to do that? If I put it here, can you see the picture? Can you see the picture? Blurry kan? Blurry. Kasha, do you have the solution? Not enough time to solve. You cannot solve. Okay. Maybe?
Oh, sorry, doctor. I got sick, so I didn't do any tutorial.
Alright. Okay. Hope you will get you know, well soon, very soon.
Thanks, doctor.
Right. Wait, I want to add the rest. Okay, I think I will share the solution with all of you in your WhatsApp group. I will forward the solution, the example of the solution given by my previous student from the other group. I will forward. Wait. Forward. Okay. All right. So hope you can have a look there. Okay, the first two is on this December 18. All right. So if you refer to the solution given there, okay, if you refer to the question, you are not required to do any drawing actually. Okay, so if you want to do the drawing, just draw. If you want to ignore the drawing, then I'm not sure whether it's given marks or not. Let me check the solution. If I refer to the solution, you are yes, you are given marks for the drawing. So I think you should draw lah. Okay, the student didn't draw. So this is a condenser, but condenser is some kind of heat exchanger also. Remember heat exchanger, chapter 7. Okay, so that is actually the same concept of heat exchanger. Condenser is actually heat exchanger lah. You have heater, condenser, it is a heat exchanger. So you have methanol on top here, and then you have water here. Okay, so same principle of that heat exchanger. The Q from the methanol being released, so that's why you got negative here. Release and then absorbed by this water stream. Okay, so if you refer to the solution, as mentioned in the question, take liquid methanol at 25 degrees C 1 atm as reference condition. So you have to follow the instruction lah. So you take the methanol at 25 degrees C. Although the inlet is actually at 90 degrees C and the outlet is at 40 degrees C, and if you refer to the question. But you have to take the reference state. So that's why you have hypothetical process path. The first given in the picture too is the hypothetical process path for the inlet methanol. So you see methanol liquid 25 degrees C 1 atm to methanol liquid 64.7, and then change the vapor and then increase to 90 degrees C. Okay, so that is for inlet hypothetical process path. And she did the calculation. Okay, so the first calculation, delta HA is 3.3. Okay, CPDT. Delta HB is 35.27, the heat of vaporization. And delta HC is 1.245. Okay, 1.245. And then she multiply and add ABC and multiply with 100. Okay, so if you do not want to multiply yet, so you can write it. See, so that one, the one shown is actually for the inlet. Show on the inlet 100 times the total is 339 something, 39.823, I guess. All right. So this is for the inlet. For the outlet, degrees C. 40 degrees C, sorry. So it's only one path. So the value is 1.2199. Okay, the enthalpy. So multiply again with 100, then you got 1 to 1.99. And then you write the energy balance. The way she wrote the energy balance is not that correct, but not enough. Okay, so you should write the energy, the general equation of energy balance. So you should write this one first. Okay, so you should write this first. Okay, then only Q equal to delta H, and then it's supposed to be N out minus in. So if you refer to the solution, to the solution given, she already multiplied 100 with separately with the inlet and outlet. So this one 1.2199. Okay, so still okay to write this, but you have to remember, you have to write the energy balance equation lah. So from there you got negative. About this value lah, I'm not expecting you to get exactly the answer given here, okay? Maybe some decimal places, different of decimal places used, so you can get other value, but it must be around this value, negative 3860.8. Okay, so it means that the methanol release the energy, the Q. Okay, this methanol release and then absorbed by this liquid stream. So for liquid stream, you are required to calculate the flow rate. Okay, so what to do? You assume that, okay, if you can recall, this is actually quite the same question with the one we discussed for chapter 7, if you can still remember, heat exchanger. Okay, where from that question, number 2, you are asked to solve. Number 3, you are asked to give assumption that you use for your calculation on B. Okay, if you can remember the question lah. Alright, so what is the assumption given there? There are two assumptions. One is open, so that's why you can use this equation. Another one is what? Perfectly isolated, so that's why your methanol, the Q from the methanol being totally being absorbed by that water stream. Okay, but that one you are asked to give the assumption. But this question, if you refer to this question, you are not even asked for the assumption, so no need to do that. So if you do not want to assume that perfectly insulated open system, so it's fine. Okay, because it's not required. So, but the most important, since we know it's perfectly insulated, so we know that Q being released by the methanol stream is absorbed by that liquid water stream. So absorbed by this water, but with different sign. So the methanol release, water positive. Okay, methanol release, water absorb. So negative, negative, you got 3860.8 equal to Q water. Alright, so next for water, to find the required flow rate, molar flow rate. Okay, so you have to assume your reference state. It's not assume lah, you have to fix your reference state. So you can use if I can draw it here, you can use, let's say this is water coming in at 20, right? Water 25 coming out 2560. Okay, so water reference state for the water, I think you should mention about the reference state of water. If not, then I will wonder what is your reference state. Okay, so you can use liquid 25 degrees C as your reference state. So if you assume this, because this one is not asked, it's not given in the question, so you can choose your own reference state. So if I choose this as my reference state, this enthalpy will be 0 because it's the same as reference state. No enthalpy required because no need to move anywhere because it's already the reference state. So this one, for this one, H2 is just water, liquid 25 degrees C 1 atm to water, liquid 60 degrees C 1 atm. Okay, so H2 is CPDT for water from 25 to 60. So 75.4 is the specific gravity, the CP. So you got this as what is the value? Give H2, if I refer to my H2, it is 2.639 kilojoule per mole. Okay, and then as we write here, as we already write it here. Okay, so you can use that 3860.8 equal to, this is the flow of the water, unknown flow rate, and this is the enthalpy. It will also Yeah, only one time of writing the energy balance equation lah. So this time no need to write anymore. Okay, because for one question, I don't think the examiner will give you marks for two times of writing the energy balance kan, only once lah. Alright, so only the first energy balance equation will be given marks, and the rest tu kalau kamu tulis lagi another 2 or 3 energy balance, you will not be given marks lah. So from here you got N as given in the slide 1462.98. Okay, mole per minute, because it is required in mole per minute. Okay, so other than that, you can also use steam table as your reference state. Okay, as I mentioned, but this one is very simple lah, because it's only 25 to 60, so better choose the inlet lah as the reference state. But if you want to choose the outlet as the reference state, fine, you can do that. So your H2 will be 0, H1 will be negative 2.639. Okay, if you want to use the steam table, okay, if you do not want to do any calculation, so you can use steam table, water, triple point, right? Triple point, and then you find the enthalpy from the water table, and then you got the N. But just be careful. Steam table, the unit of enthalpy is kilojoule per kilogram, not kilojoule per mole. So you have to do some conversion lah to get it mole per minute, because required in the question is mole per minute. Okay, molar flow rate, so mole lah. Alright, so this is for 60 degrees C. So for 65 degrees C, you follow the same procedure. It's just that you change this to 65 lah. And then you change this to 65. So you got a new value of enthalpy here, and then you get a new value of flow rate lah. Okay, follow this step. Okay, it's just changing the temperature. So if you, for this one, 65, the enthalpy will be, previously is 2.639. So if it is 65, then it will be 3.016, the enthalpy. This is what? The H2. Okay. Don't confuse. Sometimes I write H cap, sometimes I write delta H. So it's actually the same thing lah. Alright. So for that 65 degrees C is 3.016, the enthalpy. So the flow is lesser lah. Alright, 1280.1 mole per minute. Okay, follow exactly the same method. Alright, so any questions? Any questions with regard to this December 18? If not, we can proceed. Anybody?
Proceed, Doctor.
Proceed. All right. For the last question ni, anybody yang try? Anybody want to share us his or her solution? January 18? Nobody? Okay, so I will forward the solution given by my other group. Okay, Nidia already give the solution in your WhatsApp group. Thank you very much, Nidia. Did you do for this last question, Nidia?
Yes, doctor, but I found different value.
Different answer.
Yes.
All right. So I share you the So you got 1.96 kilomole per minute, and then the other one is 1282 kilomole, 1.282 kilomole, yes. All right, so for this one, I will forward, wait, I need to go to the group. Where's the group? I'll forward. So this one, it's not according to the, sorry. You know, my internet become very slow. Forward. Okay, so I forward. All right. So if you refer to the picture there, the solution there, okay, you have to refer to the second picture first, second, the with the drawing too, with the evaporator on top. So that is actually the first page lah. All right, so if you refer to the evaporator, the drawing is exactly what required lah. So you have 100 mole per second of benzene. You have 300 mole per second of toluene, liquid 25 degrees C, 1 atm. Okay, and then on top you have the gas phase, you have 80 mole per second of benzene and unknown mole per second of toluene with conditionnya vapor 20 degrees C, 1 atm. And your bottom is 150 mole per second of toluene and unknown flow rate of benzene, liquid 20 degrees C. All right. So first you need to solve the material balance. So that is the way. Okay, T balance and B balance. So you got N1. Sekejap Komah tengah kelas. Akak tengah kelas. Okay. So 150 for the toluene on top and 20 mole per second of benzene at the bottom product. And then you write the reference state. Okay, the reference state, if you refer to the question, the reference state is given. Okay, consider toluene and benzene at liquid phase 25 degrees C, 1 atm as the reference state. So you use that reference state given lah. Okay, so the reference state. Okay, so reference state benzene toluene. You can write the benzene toluene if you refer to that solution. On top there, they write B equal to benzene, T equal to toluene. It's very nice to do that. Okay, because the rest too, he just wrote BT. So if you put anywhere saying that B is referring to my benzene, T is referring to my toluene, so it will be very nice. Okay, very good. All right, so now you write the inlet-outlet enthalpy table. Okay, so benzene, liquid benzene vapor, toluene, liquid toluene vapor with all the flow rate. All right. So H1, H2. What is H1 and H2? If you refer to the solution given, 0, right? H1, H2. Why 0?
As a reference state.
Yes, as reference state. So H1 and H2 is actually 0 because it is the reference state. Okay, so the next one, okay, we should go to the last forward the image to. Okay, the last one dia kira H1, H2 dia dah actually initially he calculate H1, H2, but at the end they cancel, it becomes 0 because reference state. So H3 actually you are referring to benzene and moving from liquid 25 degrees C to liquid 20 degrees C. This one again as example given to you by the first tutorial that we discussed. So only one step or one path. So you calculate the enthalpy there is negative 0.66. Okay, and then H4 referring to benzene, but now from liquid 25 degrees C to vapor 20 degrees C. All right. So there are 3 paths involved. So you need to calculate all. So there is an error there. If you go to the final, before the final answer 25.065, you see negative 7.95. Nampak ke negative 7.95 in the answer? Negative 7.95. Okay, that value is actually not negative 7.95. It is actually, you kena add sikit belakang dia. Negative 7.95 times 10 to the power of negative 4 actually. So that's why dia dapat 25. Okay, negative 4 there. Negative 7.95 tu is actually negative 0.795 times 10 to the power of negative 4. So the answer is 3. It's not the one given, 33.02. Okay, let's do the correction accordingly. Alright, so for that benzene, 33.02. And then if you go back to the solution, the first picture forwarded, okay, H5, toluene. So the enthalpy is negative 0.784 kilojoule per mole. And then last, H6 is toluene. Okay, another 3 path. And then the value is 37.457 kilojoule per mole. Okay, so for the final answer, you should write the energy balance equation. And then, so the error is on that value of 25.065 too. It should not be that value. It's supposed to be 33.02. So with that 33.02, you will get the answer that I shown to you in the PowerPoint. Okay, which is 8125.93. Okay. Any questions? Nidia? So can you find your error, your mistake?
Yes, doctor. It's in the H4.
H4. Okay, H4. So H4, you got, what is the value that you got?
30.1061.
Oh, 30. It's supposed to be 33, right?
Yes, I guess.
It's supposed to be 33. The one shown here, 25.065, is also wrong. Okay, because the error, as I mentioned, negative 7.95 tu is error. Dia ada sepatutnya ada 10 to the power of negative 4. So some error that lah, Nidia also make error on that. So you have to be careful with your integration or that lah. Alright, because this one you have two integration of the CP. Alright, so if you refer to the question, B, to calculate the rate of heat transfer to or from the evaporator in kilojoule per second. So you give the value of Q equal to 8125.93 kilojoule per second. Is that enough? Is that enough? Do you need to do any conclusion to state whether it is to or from? Do I know it's to or from? Looking to the sign positive, I know it is actually to the evaporator kan? Positive. Okay, heat transfer to the evaporator. Am I right?
Yeah, okay.
Positive kan? But since the question still wondering whether it's to or from, so you should conclude. You should actually at the end, when you got the Q, you should write here, therefore he transfer to the evaporator. Okay, because this is to mention, to say that it is to the evaporator, because the question asks you to or from, so you need to conclude whether it's to or whether it's from. Okay, so I think that's all for today. Luckily we have the answer from Lydia and also the other group member, the other group of student. So any questions? No question.
No, doctor.
All right. So this is actually very simple question, I would say. Okay. So knowing me, my question is a bit tougher. Is that correct, Akasha? Tougher. So this is very easy. I would say this is very easy. Okay, so as long as you understand the concept lah, and as long as you understand the concept, that it will be fine actually. So next week we will go to psychometric chart. Okay, so this is another, no, it's not another, but different way of solving the energy balance. So hope to see you all again next week. All right, so that's all for today. Thank you. Assalamualaikum.
Thank you, Doctor.
Sama-sama.
Good, doctor.
Sama.